the Module 7 review. Sarah needs to save $500 by the end of the month. She makes $13 an hour and works 28 hours every week for 4 weeks. If she can only save 1/4 of her income that month, will she be able to save enough that month? If so, how much extra will she have? If not, how much more does she need to reach her goal? How much extra does she need? Does she have or need? Well, here's our goal, and this is important to acknowledge. We got to go back through this problem now that we've read it. She wants to save this $500 right there, and there's a few different ways to do this, but here's what she's making: $13 an hour, and she's working 20 hours right there. Okay, and that's every 4 weeks. So I mean, we'll just assume it's going to continue that way. So 4 weeks, 6 weeks, doesn't matter. We'll see how many weeks she's going to need, but there's another key part of this problem. She's only going to be able to save 1/4 of her income for the month. So will she be able to save enough that month? I guess that is where the 4 weeks comes in. So here's what I would want to do, and I'm not worried about the 500 right now, but I am concerned about the $13 an hour for 20 hours, and that's every week, right? So the first thing I'm going to do here is figure out how much she makes in 1 week. Okay, so this is just figuring out how many dollars she makes per week. Okay, so $13 every hour, and we got 20 of those. So 20 times 13, I'll skip a little bit of the math there, but 2 times 13, if you wanted to do that with some stack multiplication, you could, but 2 times 13 would make that 26, and tack the 0 there. So that's $260 every week. Now what I want to do is figure out then how many dollars she will make in the month. Okay. Yeah, and I know I'm not even dealing with the 4th yet, although you could have by now. Right? You actually could have multiplied the 13 by 1/4. It's going to give you a nasty fraction, so I'm hoping by doing all this stuff that it's going to make things just a little bit easier. So in 1 month, right, she's going to make $260 every week, but this is going to happen for 4 weeks. So I'm going to have to multiply this by 4. All right. Now there's a little bit of a need for some stack multiplication here. So I don't know what 26 times 4 is, but we can find out. Let's see, 26 times 4. Why am I not multiplying by the 0? Because the answer is just going to have a 0 tacked onto the end there. So yeah, I just want that 0 tacked on the end there. So 6 times 4 is going to be 24. Carry the 2. 4 times 2 is 8, but adding 2 makes that 10. So 104. And then I tack that 0 onto the tail end of that. So that's $1,040 is how much that Sarah will make in the month. All right, now, she wants to save $500, but she can only save 1/4 of this, right? The rest of it goes to bills or fun, whatever, rent, who knows. But that means that we're going to take this $1,040, and she's only going to save 1/4 of it. Now, for me, I would say, well, I would multiply that 1/4 probably in my head at least. Some of you may have said, I'm going to divide that by 4. It's the same exact thing, actually. And here's why, by the way. Because with fraction multiplication, I'd have to make that 1,040 over 1, and then use my just multiplication of numerators and denominators. Now, right now, it's all multiplied by 1, so you get 1,040 in the numerator, and then 4 in the denominator, right? Which is, again, it's 1,040 divided by 4. So let's go and use some long division to, now we're at the point where we got to do this long division. 1040, going to divide this by 4. Yeah, if you understood, even before we were doing this, divide by 4, right? Like multiply by 4, divide by 4, you're going to get 260, that's fine. For those of you that didn't, though, and I guess that's kind of why I'm doing this here. Yeah, let's go and do that long division for us. So 4 won't go into 1, but it will go into 10. 2 times 4. Yeah, and I just gave you the answer, I know. Let's subtract 10 minus 8 is 2. Drop the 4 from the tens place value. 4 goes into 24, 6. You see that happening, right? 6 times 4 is 24. That zeroes out all the tens and hundreds, so we're left with 0. How many times is 4 going to 0? 0 times. And yeah, this is how much she's going to save, right? So let's see, what was the questions here? If she can only save 1/4 of her income that month, will she be able to save enough money that month? Well, right now we're showing that she's going to save $260 for the month, in 1 month. Now her goal was this $500 up here, so does she have $500? No, she does not. So no, she will not be able to save enough this month. If not, right, we're not even worried about this part of the question. If not, how much more does she need to reach her goal? Well, she wants to save $500. She has right now $216. No, 60, sorry. So I got to subtract that. This will tell us how much more she will need to reach her goal. 0 minus 0, 0. Make that 10 minus 6. Borrowing from the 5. 10 minus 6 is 4. 4 minus 2 is 2. So she needs another $240 to make this goal here. Guess I should box that in. So how much extras does she ever need? Again, seems like that. How much more does she need to reach a goal? Yeah, that was a redundancy there. We don't really need that second question. The balance in an elementary school lunch account got down to negative $27 before the parent deposited $43. During the next month, $32 was spent. What is the balance now? All right, so starting. Right, this is how much it's starting with this negative $27. So that's what I'm going to show first. But then what happens is the parent's going to deposit. That means we're going to add $43 to this account, right? So we're looking at some integer addition. Integers with the negatives. It's negative 27 plus 43. Since the signs are opposites, one's positive, one negative, I see the positive numbers bigger, so I know my answer is going to be positive. I'm not going to put the sign there, but since they are opposites, we got to take the big number and subtract the small number. So that's 43 minus 27. 3 minus 7, I'll make that 13 minus 7, borrowing from the 4. 13 minus 7 is 6. 3 minus 2 now is 1. So at this point, after the parent deposited the $43, there would have been $16 in the lunch account. But then what happens is they're going to spend another $32. Now, for me, I would probably show this as minus 32. And for some of you, that would be enough to solve the problem. However, the way that we went over this is, since we're now taking away more than what we have, 32 is bigger than the 16, I would use keep change, change. Again, it's not a requirement, but if it helps you to solve it, then do it, okay? So I'm going to keep the 16 positive. I'm going to change the operation to addition. And then the 32, which was positive, it's going to now become a negative. So I got 16 plus negative 32. And when I solve for this, then I will have how much is now in the count. And since we're adding again, but the two signs are opposites, the 32 is bigger, it's negative, so I know my answer will also be negative. Okay? Then we just take the big number, 32, and subtract the small number, which is 16. So 2 minus 6, we'll have to borrow from the 3 there to make that 12. 12 minus 6 is 6. 2 minus 1 is 2. So it's a negative $26 is now in the account at the very end. All right, Shalia baked 48 cookies and wanted to share them equally among 8 people, including herself, so that she's included with 8 people, by the way. It's not 9 people, she's included. How many cookies should each person get? Well, how many cookies does she have? And she's sharing them equally, which indicates that we're using some form of division here. Well, what is she sharing? She's going to share these 48 cookies. That's how much she's going to start with. That's how much is being distributed. And then we're going to divide this with 8 people right there. So it's 48 divided by 8, which is, it's actually one of our division facts that we should have memorized. That's 6. 6 right there. So in the end here, it's not just 6, but it will be 6 cookies. 6 cookies for her and these people. I guess it doesn't say they're friends, but people, whatever. Ty's in charge of buying supplies. He bought 3 boxes of folders for $46 each and 2 paper cabinets for $124 each. How much did he spend in total? So right here, I see that he's going to buy 3 boxes of folders for $46 each. So that'd be 3 groups of 46. And again, this is just for the folders for now. Folders. Yeah, what do we get from this? I'm going to have to stack and multiply that here on the left. I'm going to show it as 46 times 3, though, because it doesn't matter with the commutative property of multiplication. 6 times 3 is 18, carry the 1. 3 times 4 is 12, but adding 1 is 13. So in total, for the folders, Ty spent $138. Okay, but then Ty's going to purchase 2 paper cabinets. So I'm just going to put cabinets here. I'm going to buy 2 of these for $124 each. And if I want the total amount, I'm just going to have to add these values together. What is 2 times 124? Let's stack and multiply these. 124 times 2 of these $124 cabinets. 4 times 2 is 8. 2 times 2 is 4. 2 times 1 is 2. So that's $248 for the 2 cabinets. Now we just got to add these 2 together to figure out how much the total cost is. So 248. I'll start with the 138. What the heck? And then the 248. We're adding these together. For our total cost, 8 plus 8 is 16. And the ones place value, carry the 1. 1 plus 3 is 4. Plus that other 4 is 8. Then 1 plus 2 is 3. So that would be $386 total. That's how much Ty spent for buying supplies. Eli saved $1,568 his sophomore year of high school, $2,433 his junior year, and $4,531 his senior year to help pay for a new car when he graduated. How much money did he save in total? Well, let's find out. Now let's start, I'm going to start here with the sophomore year, which is showing that he saved $1,568. So I'll just kind of organize this a little bit, but sophomore year, you're going to save this $1,568. And then his junior year, he's going to save that $2,433. This is junior year now. $2,433. And then finally, he'll go through his senior year and save $4,531 there. So there's the senior year, $4,531. So since we want to figure out how much total he saved, we're just going to add all these values together. And I'll start with these first 2 here, right? 1,568 from the sophomore and junior years. Doesn't matter if you start with these 2 years, of course not. You could have had the sophomore year and senior year, or junior year and senior year first. It's not going to matter. You should get the same answer, right? So let's start by stacking and adding these 2 together with our, I'll do that in the top left-ish. So sophomore year, right? $1,568. And then sophomore year, $2,433. Let's go and add these together, figure out how much that would be. In the ones place value, 8 plus 3 is 11, carry the 1. Tens place value, 1 plus 6 is 7, plus 3 is 10, carry that 1. 1 plus 5 in the hundreds is 6, plus 4 is another 10, carry that 1. Now the thousands place value, 1 plus 1 is 2, plus 2 is 4. So that's $4,001. And again, that's just after sophomore and junior years, but yeah, we still got this senior year, which means we still need to add the $4,531. This will tell us the total that Eli has saved here. So let's stack and add these ones together. 4,001 plus 4,531. In the ones place value, 1 plus 1 is 2. In the tens place value, 0 plus 3 is 3. And the hundredths place value, 0 plus 5 is 5. And the thousandths place value, 4 plus 4 is 8. Worked out pretty nice. We didn't even have to carry anything there, but final answer here, $8,532. That is how much Eli has saved. Rosie wants to build a rectangular deck off the back of her house. She saw an ad for a builder that said he charges $20 per square foot to build a deck. The dimensions of the deck she'd like to build are 23 feet by 19 feet. How much money does she need to hire this carpenter to build the deck? Well, this $28 per square foot indicates that we're going to need to figure out first how many square feet this deck is. So it did give us dimensions, yeah. 23 feet by 19 feet. Okay, so I want to figure out how many square feet are on this deck right. So that would be, it's a 23 by 19. So it's 23 times 19. I probably should just stack and multiply these. That's what I'll do. 23 times 19. So I should have made that bigger, but here we go. 3 times 9, that'd be 27. Carry the 2. 9 times 2 is 18 plus the 2 there is 20. So now the tens place value, anything times 1 is itself. There's the 3 and 2. We just need to add these together. So this is how many square feet this, it's a deck, right? Yeah, deck. 7 plus 0 is 7, 0 plus 3 is 3, 2 plus 2 is 4. 437 square feet of deck. That's what it looks like we're planning for this build. But then what we know is that it's $28 per square foot. So we're going to take all of those square feet, 437 of them, and we're going to have to multiply that by 28. Okay, so let's go and multiply these. In the ones place value, 7 times 8 is 15, carry the 1. 8 times 3 is 24, but adding the 1 makes that 25, so carry the 2. 8 times 4 is 32, but adding 2 is 34. Now, the tens place value, so no 1s. 2 times 7 is 14, carry that 1. 1 plus 3 is 4, plus, what am I doing? 2 times 3 is 6, but adding the 1, there's 7. I almost did addition there. And nothing to carry, but 2 times 4 is 8. So I want to figure out, this is how much total this will cost, but just adding those together. 5 plus 0 is 5. In the ones place value, 5 plus 4 is 9. In the tens place value, 4 plus 7 in the hundreds is 11. Carry that 1. Now the thousands, 1 plus 3 is 4, plus 8 is 12. So it appears that this deck will cost Rosie $12,195. So yeah, that'll do it right there. Let's go ahead and simplify this one. This is an order of operations problem, so you got to be careful with what you do. We notice, and this one kind of helps because the exponents are different, so we should know that we definitely cannot just add the bases here. Not that you should, but by the order of operations, I've got to do first -5 times itself. I'd say this, I'm going to focus on this 3 exponent first. Could you do this 2 exponent first? You could, but I'm not going to do that. I'm going to focus first on -5 to the power of 3, right? So that's 3 of these -5s, 1, 2, and 3. These are all being multiplied. And when I do multiply these together, here's what I know is that I got 3 negatives, right? 1, 2, 3 negatives. So I know my answer is going to be negative no matter what. But then I can just multiply these straight across without the negatives. Some of you would say that it's a negative times a negative is positive. Positive times a negative is negative. Either way, your answer needs to be negative here. 5 times 5 is 25. Now multiply by this last 5 there. It's going to make 125. How do we know that? Well, you could stack and multiply if you need to. 25 times 5, right? 5 times 5 is 25. Carry the 2. 5 times 2 is 10, but adding 2 makes 12. So 125. Okay? And then between these we got minus. And then we just have 8 to the power of 2. That would just be 8 times 8, which is 64. So it's negative 125 minus 64. For me, I would use keep change here. so that I can change this to an addition problem. So the negative 125 stays negative 125. The operation will change to addition, and the 64 becomes negative 64. Keep, change, change. And here's why we do that, because it's now addition, and I do want the answer here. And I see both of these are negative, which means the answer itself will automatically be a negative. And since the signs match, we're just going to take the two values and add them together. So that's 125 plus 64. 5 plus 4 is 9. 2 plus 6 is 8. Drop the 1. 189. Well, negative 189. There you go. That's it. And for this order of operations, not only do we have the square brackets, which is nice, but we also have the parentheses within those square brackets. And do recall that square brackets do represent a type of parentheses for us, okay? But within that set of brackets, we got that purple set of parentheses there, which is the first thing I need to do. 9 minus 3 is 6. Okay, now putting everything else down here, we got the 13 plus that 6. That 6 in purple there, though, remember that parentheses was to the power of 2. And we got this set of brackets. And then, of course, we'll need to divide by 3 here in the end. Okay? So that simplifies the problem. Even though it's just a tiny bit, it does simplify the problem. In fact, within this set of parentheses, I probably shouldn't have put that divided by 3. You could, though. Okay? But within the set of parentheses, I just took care of parentheses. Because remember, inside each set of parentheses, you start the order of operations again. We did parentheses. Next up would be exponents. That's 6 to the power of 2, which is 6 times 6, which is 36. Okay, so now I can look at the rest of this set of parentheses. I got 13 plus that 36. And again, I'm not going to worry about the divide by 3 because we don't really care about that right now. But 13 plus 36, let's see. 3 plus 6 is 9. 1 plus 3 is 4. 49. Okay, so that pretty much evaluates that set of square brackets right there. Last thing I need to do finally here is just divide by 3. But I guess the thing I'm noticing here is that 49 is not divisible by 3. We should not be seeing answers that are decimals yet. So I guess we got a couple options here. I mean, you could say I'm going to change it to a mixed number with some long division. I guess you could say I'm going to keep it as an improper fraction. That'd be fine, I suppose. If you did long division on this one, though, you'd get the same thing as, what is that? 16 and 1/3. So, yeah, that's going to have to do for now. So here's a fractional problem. Remember, when we deal with fractional problems, we have to treat the numerator and denominator separately as though they had their own set of parentheses. So I'm gonna simplify first my numerator, right? I guess I'll put this in the middle here so I can operate in just the numerator. Okay, now I see there's two operations, so I assume I will have to not only simplify it once, but simplify it twice. Okay? Now you got to be careful. Now I always start in the numerator. Some of you would choose to start in the denominator. It's not going to matter. But for me in the numerator, I see there's multiplication first. You can't do the 78 minus 9 first. You can't do it. All right, so don't. You got to do the 9 times 3 first. And I do know that 9 times 3 is 27. So let's go and put that in. So we end up with 78 minus 27. Which we can stack and subtract there. 78 minus 27. 8 minus 7 is 1. 7 minus 2 is 5. 51. Okay, so that's my numerator. In my denominator, I'll have to start with the subtraction there. That's 9 minus 17. Which I'm going to use keep, change, change because the 17 is too big to take away from the 9. That's going to be 9 plus negative 17 there. The 17 is bigger and it's negative, so I know my answer is going to be negative here. And then I would just have to do 17 minus 9, big minus small, which would be 8 right there. So just from that subtraction part, I end up with negative 8. Now I must add the 9. Negative 8 plus 9. I know the 9 is bigger and it's positive, which means my answer will be positive. I need to do 9 minus 8, which is 1. So it's going to be positive 1 in the denominator. That really, excuse me, that really becomes 51 divided by 1, and we know, hopefully we know by now, anything divided by 1 is itself. So we just end up with the final answer here of 51. Now this one takes us back with some of that square root business, but I think we saw some of that with this unit. But this square root right here, the square root of 121, it's really asking us, just as a review, what number multiplied by itself is 121? And while it may take some time to think about that, it's just 11. Okay. Now this is an order of operations problem. So why did I do that first? It's because we treat these square roots as though they have parentheses. You could say around them or inside them. It's not going to matter, but you're going to have to do this first. Okay. So there is subtraction, there's still division, and there's still multiplication. But I don't have to worry about that stuff because we're going to treat, and we get to treat square roots as though they are like parentheses. So this is what I end up having now after I've simplified that. And while it's not a big time simplification, it did simplify it. And now I'm dealing with exponents, which I do not see, which means I'm going to jump straight into multiplication or division. Now do be careful because, once again, some students prefer to multiply first. It's not multiplication, it's multiplication or division from left to right. So that means we're going to have to do this division first. 21 divided by 7 is 3. And to see the rest of this problem then, because that just was the division part of it, I have 11 minus 3. Now I'll have to multiply that by 5. And yes, multiplication is the next operation I must perform. So that's 3 times 5, which is 15. And now I got 11 minus 15. So some keep change here because the 15 is too big to take away from 11. That becomes 11 plus 15 now is negative 15. And the 15 is bigger than the 11, and it's negative, so I know my answer is negative. They're opposite signs. But then I got to do 15 minus 11. So 15 minus 11, 5 minus 1 is 4. 1 minus 1 is 0, so that zeroes out. So we end up with just negative 4 there. On this problem, there is multiplication between the two sets of parentheses. You just can't see it. It's there, though. And if it helps you to see it, go and put it in there, just like I did right there. But for the first set of parentheses, it's 19 minus 11. So 19 minus 11, 9 minus 1 is 8. 1 minus 1 is 0. That zeroes out, so I get an 8 from this set of parentheses. On the other set of parentheses, that's 8 plus 1, which is 9. So I end up with 8 times 9, which is 72. All right, how about simplifying a problem like this one? 10 minus 16 all over 3. Again, we treat this as though it's its own set of parentheses there in the numerator. We got to do 10 minus 16 first. So, in fact, I'll give myself some space there. Let's look at 10 minus 16 in the numerator there. 10 minus 16. For me, I would change that into an addition problem because we're taking away more than what we have. So I'm going to keep change, keep the 10 positive, change the operation from minus to plus, change the 16 from positive to negative. So that's 10 plus negative 16. And I can see that the two signs of these values are opposites. And the 16 is bigger, so it's negative, so the answer is going to be negative. And you just do big number minus small one, right? 6 minus 0 is 6. 1 minus 1 is 0. So I get a 6 in my numerator. I still have that 3 in the denominator. That's negative 6 divided by 3. Now, when we divide with negatives, we want to know if the answer is positive or negative first. Here we have a negative and a positive, which makes the answer a negative. And then you do 6 divided by 3, which is 2. So negative 2 ends up being our final answer here. All right, this one's nice. Again, I guess we're seeing less and less operation. That's okay. But we do have a set of parentheses here, so we got to start with that, right? 29 minus 25 first. That's what will go in the parentheses. So I'll do that over here. 29 minus 25, which is 4. The 2's in the tens place value, 0 out, so I got 4. Now to the power of 3, which really makes that 4 times 4 times 4. So I can do the first 4 set. 4 times 4 is 16. But then I'll need a little help with that times by 4 there. So that's 16 times 4. 6 times 4 is 24, carry the 2. 4 times 1 is 4, but adding 2 makes that 64. So a final answer here of 64. All right, here, this one is just to make sure that you have your order of operations down, which we've seen problems like this already, by the way. But here's what we would not want to see, right? We do not want to see this first. Don't do that, okay? It's going to ruin the problem for you. So make sure you stay in the order of operations. Now, there's no parentheses, though. There's no exponents, but there is multiplication first. We got to do that first. 9 times 4, which is 36. Now I can take the 86 and add it to that 36. That's going to be my final answer. Let's see what we get right there. 86 plus 36. 6 plus 6 is 12. Carry the 1. 1 plus 8 is 9. Plus 3 is 12. So 122. Final answer here. Okay, again, this is another problem just to make sure you're doing the order of operations correctly, because a lot of students would say, got to do the multiplication first. You don't on this one, because it's multiplication or division from left to right. And what do we see first? The division. Scanning this from left to right. 72 divided by 12. 72 is the sixth multiple of 12, so that's 6. Now I have 6 times 8, which we know is 48. So again, we see more testing of our order of operations to make sure we're doing this correct, because once again, there's a small group of students that would like to do this first, the addition first. You can't do that first because it's out of order now, right? There are no parentheses, there's no exponents. In fact, there's no multiplication or division, but addition and subtraction, that's all we got, and would scan this from left to right. Scanning from left to right means we got to do 41 minus 7 first. So let's see, 41 minus 7. I have to borrow from the 4 to make that 11. 11 minus 7 is 4, then drop the 3, 34. Now I will add the 22 there. So 34 plus 22, 4 plus 2 is 6, 3 plus 2 is 5, so 56. Final answer. All right, this one says to use the distributive property. So on this problem, I got to take the 132 actually and split it up into an addition problem. Then I can use the distributive property, okay? And then either way, I mean, you could say I'm going to multiply it by 8 times 132 and check my answer either way. Oh, okay, that's fine. But what I'm going to do is I'm going to take 132 and I'm going to expand it. Remember expanded form? That was several modules ago though. So that's 100. It's a 30. It's just splitting these up by place values, and these are all being added together, right? Well, what I'm going to do with this expanded form is I'm going to replace it with 132 in the parentheses, okay? So this goes back to what we've talked about just at least a little bit, where sometimes mathematics is just kind of changing the values to be what you want them to be. So in this particular problem, I don't want the 132 directly. I want it split up by its place values in expanded form. And then I would multiply by the 8, okay? So, see, this allows me to do some distribution here. In fact, I'll change the colors. So I'm going to distribute this with my distributive rainbows. There's 3 of them. And so first off, I'd have 8 times 100. So for me, I would say 8 times 1 would be 8. Then tack the 2 zeros on. Now I would have 8 times 3, which is 24. Then tack that 0 on. And then finally, 8 times 2 is 16. I just need to add all these values together. But you're going to see something like this either on the assignment or the quiz. So for me, I would say 800 plus 240. So in the hundreds place value, 8 plus 2 is 10, and then the 40. Now I can add the 16. You can stack and add those together if you'd like, but well, I guess I will here. But 1040 plus 16, 1056. So this is, there's a couple different parts to this answer. There's the distribution, and then there's the final answer here. And you could check this directly, right? You could say, well, look, I could have just done 8 times 132. You could have. So let's go ahead and check that. 8 times 132. 2 times 8 is 16. Carry the 1. 8 times 3 is 24, but adding 1 is 25. So let's carry the 2. 8 times 1 is 8, but add 2 is 10. So we get the same answer, 1,056 either way, which just kind of helps us to confirm that we did this correct. So here's more distributed property, which we will do. Again, it's going to force us to do this on the quiz or the assignment. That's okay. But I do 7 times 5 first, which is 35. That's my first distributed rainbow. Then the second one, that'd be 7 times 4, which is 28. Just need to add these two together, right? Just wanted this simplified. Well, I'm still going to solve it either way. But 35 plus 28. So it's possible that that could have been your answer right there, depending on what they want. But 5 plus 8 is 13. Carry the 1. 1 plus 3 is 4. Plus 2 is 6. So what we get when we add these two together is 63. And you would have gotten the same answer, by the way, if you just used order of operations. 5 plus 4 is 9, but 9 plus 7 is 63. Same answer, different method, I guess.